In the world today, communication is a vital part of man's life. People communicate using different languages like English, French, Spanish, and even Mongaka. Well, computer components do communicate as well. Computer communicates in order to send data from one component to another. For example, if you want to print a document, you send the command. It goes through the CPU to the printer. Therefore, there is communication between the CPU and the printer. With this, we begin to wonder what communication language computers use. Unlike humans who have a variety of languages to use, a computer only understands one language, and that language is the machine language, or you can still call it the machine code. So how actually does this machine language look like, and how does it work? Well, in this video, we shall look at how programming languages have evolved over time to become more like the natural language that humans speak. We shall trace this evolution from machine language, which is the first generation language, to the fifth generation language. But what actually is a programming language, and how is a programming language different from a program? In our previous video, we said a program was a set of instructions that tells the computer what to do in order to come up with a solution to a particular problem. Programming language is a set of instructions used to translate the user's command into a machine language. Therefore, without a programming language, we won't be able to write programs. So, a programmer is someone who writes a program. A programmer uses a programming language to write a program. There are two types of programming languages: the low-level language and the high-level language. The low-level language is further divided into two. We talk about the machine code, which we have just discussed. We talk about the assembly language, which is going to be the second generation language. Under the high-level languages, we talk about the procedure-oriented language, which is the third generation, the object-oriented, which is the fourth generation, and lastly, we are going to talk about the fifth generation computer language. So, let's begin with the low-level programming languages. Machine language. As earlier mentioned, the computer only understands one language, and that language is called the machine language or the machine code. Machine code are simply a set of binary digits of zeros and ones. A machine language is made up of numeric codes, which are strings of ones and zeros. It is considered a native language since it is directly understood by the processor. Binary language, or the binary code or the machine code, is machine-oriented and requires extensive knowledge of computer hardware and its configuration. Let's take a situation whereby you want to write hello world. In machine language, it means you actually have to write all these binaries. We have 0, 1, 0, 0, 1, 0, 0 to the end. Because machine language is far from human language, it makes it difficult to understand, and as a result, it is time consuming to write programs in the machine code, and we can easily make errors. It is error prone. If you make an error in writing a machine code, it becomes very difficult to identify the error. Looking at the example above, if you make an error during writing and you put 1 in the place of 0 in one of the binary, it automatically becomes something else. So, because of all this stress, another programming language was developed, which is the second generation language, or better still, the assembly language. Unlike the machine language, which used numeric codes, assembly language used mnemonics. For example, move, add. Let's take an example where you want to write 5 plus 6. In machine language, it would look like this: 010110. In the assembly language, it will look like add 5, 6, which is easy to understand even by humans. So, the assembly language is closer to human understanding, but not actually human language. But remember, we said a computer only understands one language, and that language is the machine language or the machine code. So what happens to programs written in an assembly language? We therefore need a translator to decode the program from an assembly language to a machine language, and that translator is known as an assembler. An assembler therefore sits between a machine code and the assembly language and translate the assembly language to machine code so that the CPU and other hardware components can actually understand. So, we just discovered that programs written in low-level languages are computer architecture dependent. That is, they can't run on other computer structures. So, if you write a program in one machine, you can't transfer it to another machine. You must have to write another program for the next machine. With all these setbacks, there was a need to step up. This led to the development of the high-level languages. So, with the high-level language, they were more user-friendly and more closer to human language. And because of its simplicity, many people became programmers and wrote more programs. If you want to write 5 plus 6, for example, in the high-level language, now tracing it from the machine code, it will look like 01000100. In the assembly code, it will be add 5, 6. In the high-level language, it will look like add 5 plus 6, which is more understandable than the low-level code. High-level codes are portable, meaning they can run on different computer structures. However, because of differences in the operating system, there may be a need for modification. For example, a program written for Windows operating system can't run on Mac operating system, hence they need to modify the line of code. High-level language is a language that uses English and mathematical symbol in its instructions. For example, addition, subtraction, division, multiplication. Now, let us go to the high-level languages and discuss about it detailedly. Under the high-level languages, we shall talk about the procedure-oriented language and the object-oriented language together for better understanding before talking about the 5th generation language, procedure-oriented language and object-oriented language. With procedure-oriented language, programs are written in sequence of steps to solve a problem, but with the object-oriented, programs are written as an interaction of functions between participating objects. The procedure-oriented language follows a top-down approach with focus on functions. With the object-oriented language, it follows a bottom-up approach where there is more focus on data. Disadvantage of the procedure-oriented language is that data is not secure. Codes are interdependent, which makes reuse difficult. But with the object-oriented language, data is actually secured and code is modular, which makes it reusable. With the procedure-oriented language, it requires low memory. Overloading is actually not possible. Whereas with the procedure-oriented language, more memory than the POL. Overloading actually is possible. An example of a procedural language, we have BASIC, we have C, we have Fortran, we have Java, we have Pascal, we have C++, we have C#. An example of an object-oriented language, we have Ruby, we have Scala, you have Raku. So these two languages, the procedure-oriented language and the object-oriented language, represent the third and the fourth generation language. But since computers can only understand one language, which are strings of ones and zeros, that is binary language, high-level language need to be translated to the machine code. This translator can either be an interpreter or a compiler. Now, with the compiler translates high-level instructions into the machine language, whereas with an interpreter, it translates high-level instructions into an intermediate code. Compilers generate an executable file like a .exe, whereas interpreters, each and every line is executed individually. Compiled codes tend to be faster since the translation is done in one step prior to the actual execution. Interpreted codes, on the other hand, is more flexible and can be run interactively. So let's take an example where the President of the United States wants to give a speech to a group of people who understand Mongaka. What happens? The President comes, and during the speech making ceremony, an interpreter comes as well, and it is translating each sentence to Mongaka. So what do you discover happening? The interpreter is translating along the way. But with the interpreter, with the compiler, the President simply sits at the office, makes a speech, and the compiler takes it and translates everything at once. And sends all of it in one bulk. So that is the difference. One advantage of using a compiled code is that it does not reveal the original source code. This makes it possible to distribute a program without revealing its inner working. When you install a software application, you are typically installing the compiled version of that code. Companies selling software applications, the original source code is a well-kept secret and gives them a competitive advantage over their competitors. So, with this said and done, we have another known as the fifth generation computer language, which is based on robotics and artificial intelligence. So far, many attempts on developing the fifth generation computer languages have failed, but a good example of the fifth generation computer language is Mercury. As a resume, we said programming languages were divided into two. We have the low-level language and the high-level language. Under the low-level language, we said these languages are computer architecture based, means you cannot actually write the code in the low-level language and take it to the next computer language. We said low-level languages, they use mnemonics. They use numeric codes, not mnemonics, sorry. They use numeric codes in their writing. With the high-level languages, we say they use English and mathematical symbols. Now, we said the low-level language were further divided into two. We have the machine language and the assembly language. With the machine language, they use numeric codes. Machine language use numeric codes, and it is the only language that the computer actually understands. That is a strings of ones and zeros. With the assembly language, it uses what is known as mnemonics. And we said for a code written in assembly language, it needs an assembler to translate that code, to decode that code to a machine language for the computer processor to understand. With the high-level language, we talked about the procedure-oriented language, the object-oriented language, and the fifth generation language. Now, with the procedure-oriented language and the object-oriented language, they need either an interpreter or a compiler to translate the source code to the object. And lastly, we have the fifth generation, which is based on artificial intelligence, that is robotics. So that is the end of the videos, dear students. If you have any question, make sure you post at the bottom of the page. And if you indeed enjoyed the video, make sure to give a thumb up, and if you haven't subscribed yet, don't fail to do that.